The next thing we're going to look at are scatter plots. Scatter plots simply show a relationship between two sets of data. Now, this wording is really important. We're going to think like scientists when we think about scatter plots. Again, it shows the relationship, not causation. Not causation. It's showing a relationship. It's not saying that one thing causes the other. It just says that they are related. For example, I remember when I was in college, in one of my psychology classes, there was this example of these researchers that did this study, and they found that in the summer, as ice cream sales went up, crime rates committed, like petty crime rates, like maybe stealing some gum or breaking a window. Well, breaking a window is not a petty crime. That is not a good thing to do. But what they found was that as ice cream sales went up, so did the number of petty crimes committed by kids your age. As ice cream sales went up, petty crime committed by kids your age also went up. Does that mean that buying more ice cream is going to lead to kids committing crimes? Does it mean that committing crimes is leading to kids buying more ice cream? Or is there something else that is going on here, right? What they ultimately found, think about it. Ice cream sales go up in the summer, especially here in Texas where it gets so hot. And what are you guys doing in the summer? Are you keeping busy with school? Nope. You have all the time in your world. So they ultimately found out is it's that free time, right? We have more unstructured, well, these kiddos had more unstructured free time, essentially, to kind of run amok without supervision. So there was a relationship between ice cream sales going up and petty crimes being committed by kids your age also going up, but that did not mean that one actually caused the other. And that's where scatter plots can show a relationship that, hey, maybe we do want to research this a little bit more and see, is there actually something going on here? It can be, just like a starter to something. But the key here is that it shows a relationship. It does not mean that one causes the other. So for example, we have hair length and height. We have dots all over the place. If there are dots all over the place, if there is no trend, then this means there is no correlation. There is no correlation. The two are not correlated. There's nothing to tie the two together. Our next one has shoe size and age. So age goes up and shoe size goes up. And we can kind of see this if we kind of draw a line here. The trend is going up. So this would be a positive correlation. I'm just going to abbreviate that because I'm going to run out of room. But it goes up, right? The trend goes up. Same thing over here. Fast food and test scores. So if we just kind of draw along the outside where we see most of the stuff, right? What direction is it going? It's going down. So we have a negative correlation. Okay, just because they are kind of lumped together. Sometimes it's going to be a little bit more obvious than others. And then we have our last one. I'm not even going to worry about what the graph says because who cares? We're focused on the relationship between what is graphed. And we can see that it's going up. So this one also has a positive correlation. Again, they are correlated. There is a relationship, but one is not necessarily causing the other. This is just showing that there is a relationship. And that's just how scatter plots work. They're just showing the relationship between two graphed pieces of data.